Hello friends, in this video we are going to discuss a previous year GATE question on electronics devices. According to the given numerical, you can see that there is a diode given Pn and the acceptor concentration is given as 10 to the power 7 per cc and the donor concentration is given as 10 to the power 5 per cc, and the electron carrier lifetime in the p side. So, this is the lifetime of the electrons in the p side, that is tau n, and the lifetime of the carriers or the holes in the n side has been provided, and the diffusion coefficient of the electron dn and the diffusion coefficient of the holes dp also been provided with the Ni, and the forward voltage 20 millivolt has been given. That means there is a forward voltage given, and this forward voltage is 20 millivolt. Now, find the whole current density in a nanoampere per centimeter square injected from the p side to the n side. That means we have to find the minority carrier concentration current density in the n side, that is injected from the p side to the n side. Now, we know that this current density is nothing but the diffusion current density. So, we can write the whole current density injected from the p side to n side is given by the diffusion current equation. So, it will be q into Ni square into dp divided by nd into Lp and into exponential Vfb divided by Vt minus 1. Now, this Q is the electronic charge and Ni is the intrinsic carrier concentration and dP is the diffusion coefficient for the holes, and Nd is the donor concentration and Lp is the diffusion length of the holes, and Vfb is the forward voltage given by 20 millivolt and Vt is the thermal voltage, and this thermal voltage value at the room temperature we know it is 26 millivolt. Now, this Lp value, that is the diffusion length of the carriers, we know can be written as root over tau p into the dp, where tau p is the minority carrier lifetime in the n side, that is the electron lifetime in the p side. So, if I put all the values in this equation, because all the values on the right hand side is given in the numerical. So, after putting all the values, we can get the whole current density injected from the p side to the n side is 286.17 nanoampere per centimeter square. So, this is the whole current density injected from the p side to the n side for the given p-n junction diode. Thank you.